Hi, I'm Tim Gilbert. I'm your instructor for BUS320, and let's talk a little bit about Chapter 3, Section 2, Measures of Center. Just wanted to point a couple things out to you, what they are, and how they relate to our histogram that we built earlier and our distribution of data. So measures of center, they're one of the most extremely important things that we look at in statistics. It's the estimate of the center of a data set. The first one, and the one we're most familiar with, is taking all the numbers, adding them up, and dividing by the sample number. The notation we use is the sum of the numbers. That makes sense, and we use sigma. X is the individual data points, and n is the number of values in a sample. Capital N is the number of values in a population. We don't use that much because we don't have the time and money to get all the population values. X bar is a notation that we use to indicate an average or an arithmetic mean. Sum of the x's over the number of samples. You can just substitute average, arithmetic mean, the sum of the individual values over n. Mu is the sum of the individual values over all the population. So if we had 100 in the population, capital N would be 100. Next measure of center is median, or the middle value, often denoted by X squiggly line on top, or X tilde. So I only show that to you so you don't see it confused with X bar. And it's not affected by an extreme value. When the values are odd, the median is a number located in the exact middle, and when the values are even, we compute it by averaging the two middle numbers. So we got 6 values. We arrange them in ascending order from lowest to highest. Take those two middle values, divide it by 2, the median's 0.915. Notice the median didn't care, it's an emotion. The median wasn't affected by how big the highest number was or how low the lowest number was. It's only interested that 3 were below it and 3 were above it. Now we have an odd number of values, 7. We put them in ascending order, lowest to highest. Median's the exact middle value, equal number above, equal number below. The mode is the third estimate of center, and it's a value that occurs most frequently. It can be used in a couple of ways. Let's see, there's a bimodal, multimodal, and no mode, and we've got examples of this. So in a data set where you have one average or arithmetic mean and you have one median, you can have several modes. And it's the only measure of central tendency that can be used with nominal data. What I mean by that is we can look at interval ratio data, the numbers we usually work with, but we also can work with it in a nominal way of saying that, let's say we had 10 cars go by, 3 Chevys, 3 Fords, 4 Toyotas. The mode would be the 4 Toyotas. So the Toyotas would be a measure of central tendency of what people were gravitating to in purchasing a car. But let's take a look at this numerical data. The mode is 1.10, and we know that because it appears twice. So one number appears multiple times. It's the only number that appears twice. We have another set of data. 27 is 3 times, 55 is 3 times. They appear in equal amounts, so it's bimodal. If 55 appeared 4 times, it would be a single mode, but in that it's tied with 27, it's bimodal. And when you have just a string of data and no repeating numbers, you don't have a mode in it. Some round-off or round-off rules for for measures of center is one more decimal place than is present in the original set of values. There's also a chart handy in your PowerPoint and in the text, and I encourage you to look at it to review and keep in mind how you work with a mean, how do you work with a median, with odd and even numbers, what a mode is, and they have a seldom used, which they put right on the chart, mid-range, the maximum and minimum, and dividing by 2. So that's seldom used, and we won't spend any time on it. Now we're going to talk a little about symmetry, and I think symmetry is not an intuitive word unless you've looked at a number of charts, but let's take a look at our histogram for actors in receiving awards and see what that means symmetrically and how that ties into where the median and mode are in average are in relation to each other. So when the data is skewed, like our actors were, I've got another chart here, I'll just go by this one. Skewed like our actors were to younger ages, there's the frequency chart. Here's the representation of the frequency chart in a histogram. When it's skewed, it'll pull things off center. Okay, the distribution kind of mounds up to the area of the bias. So one of the things that I mentioned is that you can guess by looking at a histogram. I mentioned previously, we can guess where the average might be here. Well, the average is probably just under 40. I'm not sure if it's 39 or 37. We're going to take a look at the actual calculation in a minute. And the mode's probably close in there, I would guess, because this looks like where half the data was below and half the data was above, or the median. And the mode is the most frequent data point, and I'm guessing it will occur under this peak here. So here's our distribution. Here's what it looks like. This is the way, when you see something, any distribution skewed in this direction, you'll see the mode is under the peak, and you'll see the median being a little closer to the center, and the mean's going to be pulled out. And the reason the mean got pulled out is because of these outliers here. Remember Jessica Tandy out here at 80 years old? She was out here. She's pulling that average out because we used that 80-year-old in our calculation for the average value. The median didn't care that there was an 80-year-old actress. It just said how many actresses are above the middle and how many are below.